Assalamu alaikum everyone, me Mohammad Faizan Tahir. Welcome you all to my tutorial video of ETABS software. Today we are going to learn how to design circular overhead water tank in ETABS software. So let's get started. So firstly we will open the desktop version of ETABS software. I have already opened it. In the very first step we will create a new model. For that, just click on the new model from the start page or from the menu bar. In the second step, we will initialize a model by selecting the built-in system settings and inserting the necessary credentials and standards, and press OK. In the third step, we will define the grids and story dimensions. I am putting random values here and will edit it later on. Press OK. Here you can see the user graphic interface of ETABS software. Now for editing the grid system and story data, I will simply go to the menu bar and just click the Edit tab and select the Edit Story and Grid System Data. So firstly, I will define a new grid system and selecting the grid system type to cylindrical, and will define the grid dimensions as. Press OK. I will delete the grid already defined grid system and will do some modifications here. And press OK. As you can see, the bubble size is very huge, so I will reduce it to 25. Now in the first step, after defining grids and story data, we will define the material properties. For columns and slab, I will choose compressive strength of 5000 psi. For that, I will simply go to the define tab and just click the material properties, and here I will add a new material. As I said, I will be defining 5000 psi compressive strength for columns and slab. So I will just go to the set the material type to concrete and set the grade to 5000 psi and press OK. For rebar, grade 60 will be used. I will set the material type to rebar, and as you can see, the grade 60 is already being defined. So simply press OK. Now the material properties are being defined. Now in the first step, we will define the section properties. Firstly, let's define frame sections. I will delete the multiple properties just for my convenience. Now I will simply go to the add new property and I set the section shape to concrete rectangular, and we'll select the concrete shape to circular. Now firstly I will be defining the column, circular shaped column. And the dia will be 21 inches. Press OK. I will set the material property to 5000 psi and simply press OK. So now I will be defining the slab section. The slab will be of 10-inch thickness, and just simply modeling type will be shell thin, and slab material will be having compressive strength of 5000 psi. Press OK. Now I will be defining the wall sections. Wall material to 5000 psi, and its thickness is same as slab of 10 inches. Press OK. The next step, I will define the diaphragms. For that I will simply go to the define tab from menu bar and select the diaphragms. Remember one thing, the total number of diaphragms will be equal to the total number of stories. As we are having 2 stories, so I will just simply define 2 diaphragms here and simply press OK. In the next step, I will draw the objects like slab, columns and walls. For that I will just simply go to the draw tab from menu bar. Firstly I will draw slab, and here is the procedure. Firstly I will define the material property to the slab that we have already been defined, and here is the procedure. As you can see, the slab is defined to the story number 2. Now I will define this slab. I will draw the slab to the story number 1, and same the procedure is same. So slabs are already being drawing. Now I will go to the Again, draw tab, and we'll draw the columns. For that, I will select the material property to the column. So as you can see, the columns are defined. So now I will define. So I will draw the walls here. For that, I will just simply go to the quick draw walls and go to the story number 2. Now you can see I have drawn the all the objects like slab, columns, and columns. In the next step, we will define or assign the restraints to the base. For that, I will go to the base, and from assign tab, I will go to the restraints. You can simply select all of these, and to apply, just simply select the base and click apply. As you can see, the restraints are being defined. Just simply press OK. In the next step, we will define load patterns and load combinations. So for that, I will go to the define tab from menu bar and select the load patterns, and we'll define the load patterns as After defining the load patterns, now I will define the load combinations. For that, I will just simply go to the Define tab from menu bar and select the load combinations from there. Firstly, I will add the default design combinations and select the design type for load combinations to concrete frame design and press OK. Now I will be adding a new combination. Let's just name it as combination, and we'll add the combinations. So the load patterns and load combinations are being defined. In the next step, we will assign the frame loads as distributed. So for that, I will go to the Assign tab from menu bar and go to the frame loads. It's distributed. So I'll select the wind here, and from here, and we'll define the load of 1.125 kip per feet. And to apply, I will select the base, press apply. Or you can simply go to the story number 1, select and apply. Press OK. Now I will define the frame loads. For that, I will again go to the Assign tab and define the frame loads as shell loads as uniform, because I am uh, assigning shell loads here. So shell loads are, for story number 1, I will define the uniform load of 25 pound per feet square. So we'll simply select this, click apply. That's okay. As you can see, the frame loads and shell loads are being defined. Now I will draw the diaphragms. For that, I will go to the Assign, Joints, and the diaphragms. So story number 1, I will be using D1, diaphragm number 1. I will just simply select this story and click apply. Press OK. Now we will go to the story number 1. Again, Assign tab, diaphragm, D2 for the story number 1. Just simply select the whole story and click apply. Press OK. Now you can see the diaphragms are also being defined. Now in the next step, I will check that either our model is okay or not. For that, I will go to the Analyze tab from menu bar and simply click the check model. I will select all the credentials. Press OK. As you can see that our model has been checked and there are no warning messages. As you have seen that our model is okay. So in the next step, we will run the analysis by simply going to the Analyze tab from menu bar, or you can directly press F5 and start animation. You can see that the ETABS software is preparing for the analysis. So I will start the animation here, as you can see, and let's see the analysis. Behavior of our model. Don't worry, this is just the animation sound. As you can, we have seen that that our model is being analyzed, and you can see, just simply see the deformation and behavior of our model against the analysis. So in the next step, I will go to the Display tab. From there, we will simply display the spot reactions by accessing the Display tab from the menu bar. I will select the load combination or model case to the combination and select all of these and click apply. You can see here the spot reactions at the base. So in the next step, again I will go to the Display tab from the menu bar and will select the simply we will now display the shear force and bending moment diagrams. As that, I will go to the I will select the combination here. The component selected is moment 3-3 and just simply press apply. Now you can see the bending moment diagrams at the frame. For shear force diagram, I will go to the I will be selecting shear force shear 2 -2 and just simply click OK, apply, and press OK. You can also check the shell forces. For that I will just simply go to the display tab from menu bar and will select the shell stresses or forces from here. As you can see, I want to see the mx component here. I will select the load combination to the combination we have already defined, and let's say we will assign the range to, and just simply supply and OK. So it is basically show in the plan view. For 3D view, I will go to the 3D view again. I will go to the display tab, shell forces. Let's define the range, mx from here, press apply, press OK. So you can see the shell forces and stresses behavior in our model. Now in the very last step after analysis, I will design the circular overhead water tank. For that I will simply go to the menu bar and click design tab from here, and I will go to the concrete frame design, and first of all we will view and see revised preferences. As we have selected ACI 31819, these are some standard values and I will keep them uh, as it is and will press OK. After that I will again simply go to the concrete frame design and will select design groups. The design groups I am selecting will be all, and I will take it to the right side and press OK. After that I will again go to the concrete frame design and will select design combinations. As I have selected uh, as I have defined a combination from here, so I will take it to the right side and will simply press OK. Now again I will go to the concrete frame design, and now I will start our design check. Our circular head water tank have been checked and designed. So now I will go to the concrete frame design and will display some design information from here. Let's say I will select rebar percentage. For that I will simply press apply, and here you can see the rebar percentage. Similarly we can see some other options as well, but I will simply go to the verify analysis versus design section. As you can see that analysis and design sections match for all concrete frames, so it is okay. Now I will check whether my overhead water tank has passed the analysis or not. For that I will go and select verify all members passed. Here you can see that all concrete frames passed the design check, so that means the over design is okay. That is all from the tutorial video of ETABS software. I hope you guys have loved it. Thank you so much for watching. Stay blessed. Allah Hafiz.